Alrighty, welcome back to another Pewaukee YouTube channel video. Today we're doing another Leetcode problem. We're sticking for the easy ones for now until I have more time to do harder ones because they're very hard for me. So, count special quadruplets. Alrighty. So, let's try and figure out how to do this problem. Okay. Let's see. So we're looking for... So first step is find out what the problem is actually asking, right? So that's what we need to find out first. So what is the problem actually asking? It is asking, so step one, find out what it's actually asking you to find and what it's actually saying as well. So it's saying, oops, find the number of 3 paired sets, which should be nums A plus nums B plus nums C, which equals to another number such that the kind of numbers are, how do I say, I guess, I don't know, such that, oh, I see, such that the indices of the numbers in the list are strictly increasing. Okay, that makes sense. Hopefully that makes sense. Let's see. Find the number of 3 paired sets, which equals to another number, such as the indices of the numbers in the set. I guess it's a 4 paired set. 4 numbered sets, which equals to another number such that the indices of the numbers are strictly increasing. Okay. And yes, the number of 4 numbered sets. Okay. Step 2 would be find or determine some solutions from examples. Okay, so let's try and think of our own special example. Let's say it is 2, 4, 5, 6, 10. Let's just say it's sorted like that. Might have to sort every input, but we'll see. And what we need to see is we need 4 kind of numbers that add to be one number. So if we take 2, 4, and 5, it's not quite equal to 10. It's equal to 11. If we take 2, 4, and 6, that's 12. So here we would actually have a 0. So answer 0. Okay. And then we need to see another example. Let's think of 1, 1, 1, 3, 5, which is given there. 1, 1, 1, 3, 5. So 1 so 1 plus 1 plus 1 equals 3. So that's 1 of the solutions. And then 1 plus 1 plus 3 equals 5. That's another solution. Let's see, what are the other solutions there? Oh, wow, okay. So we need to use all the various ones. So I guess 1 plus 1 plus 3. This would be, let's say this is index 0 and index 1. This would be index 1 and index 2. And then this would be index 2 and index 3, the 1 plus 1. Or sorry, 0, 1. Then 1, 2. Then this would be 0 and 2, technically. 0 and 2 equals 5. Oh, wow. That's interesting. Okay. Let's think of one more unique example. Let's say 2, 2, 4, 6, 8. Alright. So here, I believe we'd have two solutions. So we'd have 2 plus 2 plus 4 equals 8. Never mind. It's the only solution. So we just have 1. So here we'd have 4. And here we would have 1 solution. And there we'd have 0. So what are some kind of patterns here that we could try and recognize? I'm not quite sure. Maybe the fact that, what am I trying to say? Maybe it's the idea. Oh, I'm running out of words. I think it's just that we need to loop through all the elements, and we need to have this you need to have these 4 pointers or something. That's a lot, but yeah, we need to have these 4 pointers. So, okay, well, we could think about this. Every problem needs 4 pointers, or every type solution needs 4 pointers. We can make that kind of generalization because it makes perfect sense. So it's A, B, C, and D. Okay, so I think looping makes this very simple. So let's say looping makes this simple. Let's say we had something like, so let's say it was sorted. So let's have another example. Let's say there was something like 2, 2. Let's say it was 2, 2, 3, 4, 6, 8. So the answer is still 1. So it's 2 plus 2 plus 4 equals 8. But in the first iteration, we have 2 plus 2 plus 3 is 7. So if the list is sorted, this means that, okay, if 4 is not 7, then we keep increasing. And if there's an element which is greater than that addition, then we want to take this pointer and add 1. And then we want to see what that adds to. And then say, okay, see if we can find that, which we do. And then we add 1 to our solution. I believe that's the way we should go about this. So 3 would be to make some make some observations for the solution. A sorted list would probably work much better to find all the combinations. Alright, so the only thing with this, or no, sorry, that's not what I was trying to say, but I think this, in the assigned cookies video, I had explained that this may, touch with some time constraints, but if we use sorted nums, I don't know if Python has a way of saying this is a sort of only integers, so we can do a radix sort. If you don't know what a radix sort is, it is a special sort used only with integers where you separate the input numbers into what's called buckets. And then you kind of, take these values from buckets and put it in correctly sorted order, which is, this time complexity is only O(n). So I'm not too worried about, a time complexity going too far, for example, or just taking too long, especially since the constraints are the nums.length is only to 50. So it should be quite simple then. we should not have to worry about that at all. So now, let's break it up into much smaller parts. Let's see if you can see that. No. Okay. So break the problem up into smaller parts. So step 1, set a result variable to 0. Step 2, set all the pointer variables. Pointer variables to their respective points, to their respective, I guess points. I don't know how else to say it. So A equals 0, B equals 1, C equals 2, D equals 3, for example. And then we need to say loop. Start a loop to see if the addition of A, B, and C is equal to D. Of course, the proper indexing of the array, not just the indexes themselves, because I guess this would prove true anyways. If not, increment D till the end of the list. And then we want to bring D since it's sorted, not to the end of the list, till, let's say, end of list, or until there is a number greater. Until there is a number greater than D. Then the sum. And then, if there's a number greater than the sum, then what do we want to do? So for this example, if it's 2 plus 2 plus 3, then we say, equals this would be the D. So we'd increase, we would say 8 is greater than the sum of 7. So we would say D is equal to C plus 2, you could say, for example. And then we would say C plus 1. And similarly, then we would say, we would find that sum when we would go to D. Then we would say C plus 2 all the way until C is, let's say C reaches the 6 here, and there wasn't a summation. Then we'd want to bring the C back to C plus 2, and then say B plus 1, I think something like that. So how would that work? Let's say if, I think I need to bring this down a little bit. I don't know if it's all showing. Okay. If the D index reaches the end, set equal to C plus 2. Or no, that doesn't matter because it already goes past C plus 2. So we want to set C equal to B plus 1. And then D equal to C plus 1. And then we want to say if C reaches end, set B equal to c plus 1 and d equal, wait, set b equal to, wait, I guess it would just be b plus 1. Not a plus 1 because it's already at a plus 1. So set c equal to c plus 1. This should be c plus 1. So d equals c plus 1. If c, okay, then if c reaches the end, or this would technically be like len minus 2 because we still need room for the d, then we would say set b equal to b plus 1. It's b plus 1. C equals to b plus 1. D equals to c plus 1. If a oh wait, if b reaches end, then set a equals to a plus 1, and so on. Okay, so let's try this solution in code. Using Python today, so let's take a look. Alrighty, so the first thing we need to do, step 1, because step 3 was a super long step, I didn't even see that, but set a result variable. I guess we can combine step 2 as well, and set the index vars. Set the result and index vars. Res equals 0. I guess we could just do result. Set the result variable. Set the index variables. So we'll say a equals 1. We'll just go with the or 0. B equals 1. C equals 2. D equals 3. And now we need to start a loop. Start a loop. Oh, I'm forgetting to sort the list. So we're gonna say nums.sort, which might use a radix sort. I wonder if it does. That'd be very interesting. Because then it'd only be on time because of integers. So we're gonna say start a loop through or to C if the addition of A, B, C, and D. Oh, A, B, and C is equal to D. Okay. So we're gonna say, what should be the proper statement here? Probably, while D is in range, while D is less than len nums, we're going to say sum equals nums A plus nums C, or B, oops, I forgot B, plus nums C. And then we're going to say if, what is next? Ah, yes, okay. Check if sum is equal to dth element. Let's say if sum equals D, nums D, then we're going to say count res, plus equal 1. And then what happens after that? I guess we would want to increment D plus equal 1, because we want to see if there are two 8s. So let's say in this one here, if there are 2, excuse me, or here. Or no, is it not this one? No, it's not quite this one. So let's say in this one here, if there was an extra 6 added to the end, then we would want to say, okay, 1 plus 2 plus 3 is 6, which is a distinct quadruplet, and then 1 plus 2 plus 3 equals the other 6. So we want to say that. And we want to say, let's say, if d equals, actually no, I should say this here before. Check if d is about to be out of range. If d equals len nums minus 1, then we need, what do we need to do? Set the c value to increase, because you're evaluating it at the last d value, so you want the c value to increase. C plus equal 1, and then we want the d to be equal to c plus 1. If c equal n nums minus 2, then we want b plus equal 1, c equals b plus 1, d equals c plus 1. Set the c value to increase. Set the b value to increase. And then if b is at the end, len nums minus 3, we're going to say a plus equal 1, b equals a plus 1, c equals b plus 1, oops, c equals b plus 1, and d equals c plus 1. Okay, that sounds a little bit confusing to me. Because what if it's this? Then what happens? They all increase? That's no good. Uh-oh. Set the a value to increase. But now this is a bit confusing, because now if we do this, oh, the sum is still evaluated here actually. But then, let's just say else if. Right? Yeah, that makes sense. So what if it runs on d? So d is technically equal to num. Then it'll say d equals c plus 1. Hold on, let's think of answer is supposed to be nums d. So we want to get that at the start, and then we want to say sum equals answer. I believe this is what we want to do. Does this even pass the first case, I wonder? Oops. Syntax error. Oh, it's elif in this language. Man, I always forget that. Ay. Okay. It actually does work. Alright, fantastic. Let's get this here. This test case. Let's see what happens. Seems to be taking quite a long time. That's strange. I don't know what's happening. Oh no, time limit exceeded. What happened? Wait, so let's take a look at what happens there. So we have, well, if we sort that, we'll get 3, 3, 3, 3, 4, 5, 6. So it'll be, well, d is less than len nums, so d is currently 3, and the length is 5. Sum equals, what am I trying to say? I'm not sure. Oh, I think I know what the problem is. Maybe? If A reaches the end and you make a check, then it should break afterwards. But then it would say that you would update A. Huh, I'm not quite sure. I must think. Well, the sum would be, let's think of 3, 3, 4, 5, 6, right? When it's sorted, the sum at first is, oh, can't I check to see if the num at D, one of my checks was that until the end, not increment D till the end, or until there's a number greater than sum. Oh, I forgot to even increment D in the first place. D plus equal 1. D has to be incremented. Let's see if that just gets the, okay, just gets the error out. Well, let's test this case too while we're at it. Why not? Okay, only got one case. So that's not what we wanted. So what happens here? What happens here might be that, let's see. So 1, 1, 1, 3, 5. So 1, 1, 1 equals 3. Sure, it passes that. Then we get 1, 1, 1, 5. Doesn't pass that. Then we shift up the C variable. So we say 1, 1, 3, 5. Fantastic, that should work. Because 1 plus 1 plus 3 equals 5. Let me just print the sum to see what happens. 3. Oh, that's it. I feel like the checking has to be before. Maybe. Actually, does that matter? What if we do this? What if we put the checking before? And we say, okay. So check if D is about to be out of range. Okay, that makes sense. What if this makes more sense? Okay, maybe it's bad to just test like that, but. So we get the first one, right? So we get the sum, the first sum, but then we don't get anything else. So we have, if the sum is equal to the answer, then rows plus equal 1, D plus equal 1. D is not at the end yet, so that doesn't happen. This doesn't happen, and I don't believe this happens either. That does not happen either, so none of these happen and D gets incremented. Okay, then we get 1 plus 1 equals 5. That doesn't happen, or that should be printed. Or perhaps I should print the answer instead to know where D is at. So you could figure out where that D index is at. Should get 3 and then not 5. That's a bit strange. So if we print the answer, we get 3. So that's where the D is at, and then sum is equal to the answer. So res plus 1, D plus 1. Oh, then D gets added again. And then D is not less than the length of nums. So we need to put this in an else, I believe. Or maybe it doesn't matter if it's in an else. Or yeah, I can just say continue. continue. So then it'll do the next iteration. 3, 5. Oh, that's okay. So we got to the 5. And then this should print. This should run. Let's just make sure this runs. I believe it should. Okay, good. So d is equal to len_nums minus 1. That happens. So then we say c plus equal 1. This is c. So c should be here. And then d should be here. Okay. And then what do we need to say? That is false. Because 1 plus 3. Wait. No, where is this supposed to go? Hold on. That would be right. So 1, this is A, this is B. This will become the new C. So it should be equal to that 5. I believe. Let me just print D here. Get rid of this for now. D is 4, which is at the end of the list. Good. And now, what if I continue? Because we don't want to add D again. That's what's happening. I'm adding D again, but I don't want to do that. Only if none of these get reached, basically. 2. Okay, so we got 2, and then I assume this runs when it's at the end. The C is at the end. So make sure. Let's see. Ah, it does not. Really? Huh. Well, that's interesting. 2 and then 4. That's what we want, so. Let's print C here. And I want to see it be 3. I believe, okay, 3. Good, so then when I run again, then what do I want to have? So sum equals to 5. And then that gets added. Good, so then the only problem now is that C is equal to len_nums minus 2. So why doesn't it run? Because this will run first. And it'll add C. So I think I need to do it in the reverse order. Oh man, that sounds confusing. But I think if B is there first, you need to kind of take care of, how do I say? I think if, I feel like that makes sense though. If this C is at 3, I feel like it just has to be switched. I don't know how to explain it, but. So this will be if, this will be elif. Okay. Okay. Elif, and this will be here. I feel like we're just supposed to check the B first. So check if B is about to be out of range. Check if C is about to be out of range. I feel like this makes more sense doing it this way. Okay, that did not. Did this run? That should have ran, right? Ah, it did not. That's unfortunate. Probably because of this, no? What is beta? So C is 3, then B is 2. What if they could all just be if statements, but they have to be updated separately? Does that make sense? Let's see if this runs. This is a bit confusing. Might have to come back to this one in a minute. So I'm a little confused on what I'm doing wrong here. 0, 1, 2, 3, 0, 1, 2, 4. 0, 1, 3, 4. That's what I want. 0, 1, 3, 4. That's what I want. And then what happens after that? So C is equal to 5 minus 2. That should be printing true. That should be running. Right? That's what I think. It does not though. It's very strange. Perhaps it continues by just adding D, and then D is out of range. I believe that's what happens. So how do I check that? Actually, just remove this, remove these 2 lines, so replace with 1. Because then this D plus 1 will, there it is. Alright, let's see. If 3, 3, 6, 4, 5. Let's take a look. Okay, cool. So I think that's it. Makes sense to me. Just a lot of checking things. Oh, it's judging. Oh, it's taking a long time to judge. I don't like that. Oh no. It's not good. Alright, we are back. And I think I figured out the issue is that, so when I was looking at, so I tried to submit, I had a problem with this answer. And then I realized you're not supposed to sort the numbers. So, there's no reason to sort the list. Because then you get this, and when written out is going to be 8, 8, 20, 28, 37. This is when sorted, by the way, 49, 85, and 90. And when it's sorted like this, there are actually 3 different additions that equal 85. So that is not what we want. We just want the list to be not sorted. So this should work then, I believe. I hope. Big moment of suspense. Let's see. Alrighty. Wow, that was the slowest runtime I think I've ever gotten. What? Okay, let's see a faster solution. Because my runtime is literally off the charts. Okay, I need to see a faster solution for this. Alright, pairs equals default dict. I don't know what that means. Let's take a look at it. I don't know what default dict means. Count answers equals collection.counter 0 for AC. I don't know if I understand this either, but can I get something I understand? Okay. Pairs equals times 201. A list of 201 elements. Triples of 101 elements. Pairs of... I don't know what this is saying. Let's take a look at something given somewhere in the middle. Let's say, okay, right around here. It's a O of n to the 4th? Oh, that makes a lot of sense. That makes a lot of sense. That this will actually only run one time, at least in the first case. Now it should be perfectly fine. There we go. So this is a much more straightforward solution than what I'd come up with. But it just proves again that there are multiple solutions to every problem. Alrighty. Thank you for watching. I hope my roundabout solution was hopefully in some way helpful, and I'll see you in the next one.